Hello dear, welcome to General Chemistry lecture series, and we are working on chapter number 1, which is chemistry, matter and measurements. And so far we have gone through 4 topics, 1, 2, 3, 4, and then you can review those topic with my previous videos, and I have added the link. And in this video we will study about the units of measurements, metric system, SI unit, volume, density and scientific notation. So these are some basic number and units measurements we will study in this lecture. So hopefully you will learn from this lecture, and if you have any question or comments, please type your question and then I will answer as soon as possible. Thank you. So let's understand the units and number in this general chemistry course. So numbers and chemistry, many properties of the matter are quantitative. It means there are some numbers are related or associated with the many different types of properties of the matter, and number play a major role in the chemistry, and many topics are quantitative. It means they have some number values, and what kind of numbers will be associated in this general chemistry course. So you will see units of measurements, what are the units associated in the measurements, and quantities that are measured and calculated, uncertainty in measurement, significant number, dimensional analysis. So these are the topic we will study one by one, which are related to in the quantitative aspects of this matter. So first is unit of measurements. So basically there are 2 types of unit system are reported and we are using. First is called metric system, which was developed in England in 1800 century. This is also called English system, and it is also called MKS system. MKS means meter, kilogram and second. So we'll see what are the base unit of the metric system. And then SI unit is international system of units, so which was developed in later after the metric system, and most of the time we are using SI unit, but some of the common metric system of unit will also use. So what are the common base units, SI base units? So mainly there are 7-8. So length, mass, temperature, time, amount of substance, electric current and luminous intensity. So these are the physical quantities which we measure or study in the general chemistry. And length have name of unit is meter, mass is measured in the kilograms, and the abbreviation for the meter is small m. Kilogram abbreviation has capital K and small g. Temperature is measured in Kelvin, capital K. Time in second is small s or SEC. Amount of substance is measured in the mole, MOLE it's written, and its abbreviation is MOL, mole. Electric current is in ampere and its unit abbreviation is capital A or AMP. And luminous intensity, candela, and its abbreviation is CD. So I have very few time I have used candela in the physics chapters, but not in the, or you can say physical chemistry, but not in the general chemistry. So but still it is considered to study in this chapter. So and if we talk about the units of measurement in metric system, so there are 7 type of unit system which we have to study in this chapter. So number 1 is length, which is measured in meter and abbreviation is small m. So you can see there are some length mass, temperature, time, and amount of substance, they are common in both the system, metric system and SI system, and their units and abbreviation, everything is same except the two things, the volume and density. So volume is and density both are considered as a derivative of SI unit, or basically it have two units together. So volume is measured in cubic centimeter. Cubic means 3 times you have to multiply with the same unit, or liter. So cubic centimeter means, and its abbreviation is cc, and liter abbreviation is small l. So cubic centimeter means centimeter multiplied by centimeter multiplied by centimeter, so like cube, so 3 times you have to multiply this unit. And density is measured in gram per cubic centimeter, and abbreviation is gram per centimeter cube. So let's study about the next very important topic, that is scientific exponential, or scientific notation. It is called scientific notation or scientific exponential. Hi dear, in this video we will study about the scientific notation, and before that let's see how scientific notation help us in solving math. So why we need scientific notation? Basically in science we deal with some very large numbers. For an example, 1 mole is equal to 602 and 0000, so many zeros are there, 21 0 actually. In same way we also deal with some very small numbers. For an example, mass of an electron, which is equal to 0 decimal 0.0000031 and then 91 kilogram. So you can see how small is the weight of electron. And now if a question is asked to find out the total mass of 1 mole of electron, then think the complexity of the calculation, how difficult to calculate the mass of 1 mole. So basically we have to multiply mass of one electron, which is 0.310 and 91 kg, with 1 mole value, and then how we will manage all these zeros. So to at this point scientific notation come at place and help us our math. So basically scientific notation, also called scientific exponential or standard form or standard index form. This is a method or way to handle a very large or very small numbers, which are written conventionally in decimal places. So there is one set of standard method for writing scientific notation, which is a very simple formula, that is a times 10 raised to the power of b. We read in this way, this formula, where a is a coefficient and it can be any real number, and b is an exponent that can be an integer. So let's take an example. If we want to convert 100 into scientific notation, we will write 1 times 10 raised to the power 2, and if we want to convert 9500, this will become 9.5 times 10 raised to the power of b, raised to the power of 3. In example number 2, if we want to convert 0.01, this will become 1 10 raised power of minus 2, and 0.0095 will become 9.5 into 10 raised power minus 3. So let's see how we can convert these values into scientific notation. Here we are taking two examples. In the example number 1, we are going to convert 1,500,000,000 into scientific notation a times 10 to the raised power of b. So you can see there is a no decimal point. So let's add an arbitrarily 0 at the right place, right hand side, and then we will move this decimal plate one by one all the way just before 1. So let's move up to here, and we have to count how many places we move. So 1 2 3 4 5 6 7 8 9. We will move this decimal place up to ninth place, and then we can write the scientific value as a 1.5 times 10 to the raised power of 9, because this 9 is an exponential, and it comes that how many times, how many places we move, how many times or how many places we move this decimal place from right side to left. We have to move decimal place only up to first integer. I mean, we have to place this decimal just before first integer, not after this. So this is the rule of scientific notation. Let's see another example, number 2, where we have to convert 0.0000623 into scientific notation. Here we will move our decimal from all the way left side to the right, and we will put this decimal just after first integer or first non-zero value. So let's move first, second, third, fourth, and fifth. So we will move this decimal place up to 5 places, 5 times. Then we will write the value 6.23 times 10 raised power minus 5. So minus 5 because we move this decimal place 5th place from left side to right place side. So this is the way how will you convert normal decimal values into scientific notations. Here is one more thing important. If we are moving decimal place from right side to left side, for an example in 1, then exponent value increases, means this one small b, or here 9. In example 2, we move decimal place from left side to right side, therefore exponent value decreases. You can see minus 5 is much smaller value because we move decimal place from 5 times or 5th place from left side to right side. So this was the about the scientific notation. We will see some more examples: addition, subtraction, multiplication, and division in another video, and I hope you will like this video. Hello dear, thank you. Welcome back in scientific notation topic. Here we will study about multiplication and division. So as we know, scientific notation, we have to write like a times 10 raised power b, where a is coefficient and b is an exponent. So let's take one example for multiplication first. If we have to multiply 1.06 10 raised power 4 with 2.58 times 10 raised power 5, so how we will multiply with these two units of scientific notation? Basically we will divide these two into two parts. We will multiply coefficient first and raise power or exponent separately. So first let's use multiply coefficient 1.06 from this number and multiplied by 2.58 from another number, and then on exponent side, when we multiply 10 is power 4 with 10 is power 5, when we multiply with these powers, basically these powers got added, In multiplication, the raised power or exponent got added, so the result will come 2.7348 and 10 raised power 9, because we are going to add 4 and 5. So final number will come 2.7348 times 10 raised power 9, and if we will use a significant figure, then we can write final answer 2.73 times 10 raised power 9. So this is very simple. You have to just multiply coefficient and then exponent separately, and then add power in exponent. And let's take another example of division, where we have to divide 8.42 times 10 raised power 7 with 2.15 times 10 raised power 3. So once again we have to do same thing as we did in multiplication. We will divide coefficient separately and 10 raised power um, separately. So 8.42 divided by 2.15 and raised 10 raised power 7 divided by 10 raised power 3. So when we divide 10 raised power, then powers got subtracted. So in multiplication we have to add, and in division we have to subtract these power. So the answer will come 3.9162 when we will divide 8.42 with 2.15, and raised power will be subtracted from 7 to 3. We will get 10 raised power 4. So the answer will come 3.9162 10 raised power 4, and according to significant figure we will write 3.92 10 raised power 4. So it's very simple. We have to just multiply or divide coefficient separately and exponent or 10 raised power separately. In multiplication you have to add the power, and in division you have to subtract the power. Let's take another example. When number we get bigger than 10 or smaller than 1, so how we will manage? And before that, we have to I would like to remind one rule, that if we will move decimal right to left, we increase the exponent value, and when we move decimal point left to right, then the exponent value decreases. So let's take an example. Example number 3 is 8.25 times 10 raised power 6 multiplied by 4.55 10 raised power times 10 raised power 3. So once again we have to multiply coefficient and exponent separately. So 8.25 multiplied by 4.55, and then 10 raised power 6 multiplied by 10 raised power 3. So power will got added, and then answer will come 37.5375 and 10 raised power 9. So final answer will come 37.5375 10 raised power 9. But here is, according to scientific notation rule, we always place decimal after first integer or after first non-zero value. So we have to move this decimal from left to right, and when we will move left to right, you can see the according to rule, sorry, right to left, we are moving right to left this decimal. So when we move this decimal point from right to left, the value of integer will increase. So let's take a look. 3.75375 times 10 is power 10, so this 9 will become 10, and according to significant figure, final answer will come 3.75 10 is power 10. In case of division, let's take an example number 4. 3.16 times 10 is power 5 divided by 3.75 times 10 is power 9. So let's see how we will divide these two. Again, we will divide coefficient separately and exponent. So 3.16 divided by 9.75 and 10 is power 5. divided by 10 raised power 9. So as we seen that in division we have to subtract these exponent values or power. So 5 minus 9, and then the value will come 0.3241 10 raised power minus 5. So we have to include this sign also, because 9 is bigger than 5. So once again we will write 0.3241 10 raised power minus 5, but according to scientific notation rule we have to place this decimal just after first integer or after first non-zero value. So we have to move this decimal left to right, and when we will move this left to right, the exponent value decreases. So decreases means we have to write answer like this: 3.241 times 10 is power minus 6. So minus 6 is lower than minus 5. So the final answer will come after significant figure rule: 3.41 times 10 is power 6. So here we have seen multiplication and division and 4 examples. I hope you understand, and if you have any question, please comment, and we will see addition and subtraction in another video. Hello dear, welcome back on scientific notation topic. Here we will study about the addition and subtraction of scientific notation. uh, I would like to remind as scientific notation written as a times 10 raised power b, where a is a coefficient and b is an exponent. So let's take an example of addition of scientific notation. There are two values here, 1.06 10 raised power times 10 raised power 5. We have to add with 2.58 times 10 raised power 5. So here I choose an example where both the exponent are same, and we have to, let's see how we will add those. So as we did in multiplication and division, we have to add coefficients from both the sides and add together. So 1.06 and added 2.58, the value will come 3.64. And here is important thing that 10 raised power 5 are is common on both side. So we will write as such. Here we need not to add or divide or multiply these powers. Just if they are common on both sides, just take as it is and write in your answer. So final answer will come 3.64 times 10 raised power 5, and that's it. Let's take another example where we are going to subtract 2.15 times 10 raised power 3 with 8.42 times 10 raised power 3. So here also I also choose same 10 raised power on both the side. So both the values have common exponent. So we will do subtract 8.42 minus 2.15. The answer will come 6.27, and since both the exponents are common on the both sides, so or 10 raised power are same, so we can write as it is 10 raised power minus 3. So the answer will be 6.27 times 10 raised power 3. So in here I have taken two examples where 10 raised powers are same in both the examples. Let's see another example where these 10 raised power or exponents are not same. Then how we will solve addition or subtraction? So we have to keep in mind the two rules. If we are moving decimal place from right to left, then exponent value increases, and if we are going to move decimal point left to right, then exponent value decreases, right? So let's take an example number 7 here, where we are going to add the values 2.25 times 10 to the power 5 plus 4.55 times 10 to the power 6. So here you can see the 10 to the power are not same. So what we will do, first we have to make these powers same. How we will make them? So here we will move this decimal point one place left. So the final coefficient we will get 0.225, and the whole number will change like 0.225 times 10 to the power 6. So we move this decimal one place on left side, that is why this power will become one time increase. So we have to increase this 10 to the power 5 to 10 to the power 6. Now the new value will become 0.225 times 10 to the power 6, which we have to add with 4.55 times 10 to the power 6. So now we have common 10 to the power or exponent on both sides. So it's easy again. We have to just add these coefficients together, 0.225 and added with 4.55. Answer will come 4.775. And now the exponent and 10 or 10 to the power are same, so we can write exactly as such in the answer. So final answer will be 4.775 times 10 to the power 6, and if we will use a significant figure and round up rule, then final answer we can write 4.78 times 10 to the power 6. Let's take another example where we are going to subtract and the power are not same. So we have to subtract 4 4.55 times 10 is power minus 12 with 3.25 times 10 is power minus 10. So here again we have to first make the power same, then we will subtract. So what we will do, we will move this decimal in 4.55 times 10 is power minus 12 value 2 points left side, left to right side. So this decimal will move here before 4 and then one place more, then we will get a new number which will be 0.0455 times 10 is power minus 10. Since we move the decimal two places to the left, that is why this 10 is power minus 12 will increase two places. So it will increase like 10 is power minus 11 and then 10 is power minus 10. So that exponent value increases. Then we will get two number 3.25 10 is power minus 10, and another value, another number is here 0 0.0455 times 10 is power 10. So now we can see 10 is power are same in both the numbers. Now we can subtract these values. So 3.25 minus 0.0455, the answer will come 3.2045 times 10 is power 10. So now you can see that on both the side exponent or 10 is power are same, so we can write as it is in the answer. And then final answer will be 3.2045 times 10 is power minus 10, and if we will use a significant figure and round up number rule, then the final result will come 3.20 times 10 is power minus 10. So here we have seen the how we will add or subtract scientific notation values if 10 is power are same or different. I hope you will understand or you enjoy this one, and we'll see more in other videos. So here is one more example for writing the scientific exponential notation. If you have to write these long number, what you do, you have to add one decimal at the end on the right hand side, and then keep moving this decimal all the way to the before first integer, and then you have to count how many zero or how many places you have moved this decimal. So 1 2 3, so basically if I will move 1 2 3 4 5 6 7 8 and 9, so I can write this number in the form of scientific number like 2.5 times 10 raised to power 9. And in another question, this is 0.0000579. so what you have to do here, you have to move this decimal point from right side to left side to right, and just place it before first integer. So and then you have to count how many points you have moved it. So 1 2 3 4 and 5. So the answer would be 5.79 times 10 raised to minus 5. So if we move right to left to right, basically this number is very low, very small. That is why you have to write minus 5, 10 raised to minus 5. And let's take one more example. So far we have seen scientific notation and its calculation using without using calculator. Let's see if we have to solve this question, if we have to calculate with this scientific notation using calculator. If we have to divide 5.44 times 10 raised to power 7 gram divided by 9.8 times 10 raised to power 4 mole. So using this TI30X2S calculator, how will you use it? So what you have to do, I already have written here what is the formula you will type, but let me show you once again. So it's you have to type first 5.00, and then you have to, how will you type this 10 raised to power 7? So you have to hit second, and then this is one more button, it is written here EE, so click EE and then click 7 divided by 9.8, and then again second, and then EE and 10 raised to power 4. So you have to type only 4, and then equal to, so answer will come here. You can see 5.55 and then 10 raised to power 2. So the answer will come like this one. So this will be like 5.55 10 raised to power 2 gram per mole. And one more example, if you have minus 4, then how will you solve this question? So let me clear this and then type once again 5.44 second EE 7 divided by 9.8 second EE, and then minus 4, 10 is for minus 4. So don't use this negative sign, it is subtraction, so you have to use this sign as a negative 4, and then come answer. So answer would be for this question 5.55 times 10 raised to power 10. You can see it's 10 raised to power 10. So this way you can use calculator also to solve scientific notation problem. So let's see another topic. So if we have to solve or compare the metric system metric conversion of length. So to convert meter to millimeter, if we have to convert 1 millimeter into so what would be, how we will find 1 millimeter is how many meter? So usually it is 1000 meter, and which is equal to 10 to the power minus 3 meter, or 1000 millimeter is equal to 1 meter. So how we will find this milli? What is the meaning of milli? And so for that you have to go through with this prefix in your book. So you will see this table, there are written many prefixes: penta, tera, giga, mega, kilo, deci, centi, milli. So milli is 10 to the power minus 3. So you can use this prefix with any unit. Here in this table they use watt. So this is the watt is a SI unit of power. So here this gave you that 1 milliwatt, 1 centiwatt. So 1 milli means 10 s. So you have to replace milli like a 10 to the power minus 3. 1 centi 10 to the power minus 2. 1 deci 10 to the power minus 1. So usually we don't write minus 1. Kilo is always 10 to the power 3. It's positive. Means you have to multiply by 1000. And then 1 megawatt is 10 to the power 6. Gigawatt 10 to the power 9. And there are, so from here you can see the numbers are increasing, and from here to here the numbers are decreasing. So this is a deci, centi is 10 to the power minus 2, milli is 10 to the power minus 3, micro is 10 to the power minus 6, nano is minus 9, pico is minus 12, and then femto is 10 to the power 15, a, auto, and zepto. So these are the prefix you will see in the calculation. So and then how, if you see these prefixes, you have to use these values or these number as a 10 to the power minus 3 minus 1 or plus 3 plus 1. So let's, using this, keeping this in mind, let's solve this question. Select the correct relationship between these metric unit of length or distance. So what would be the correct conversion? 1 kilometer would be equal to 100 meter. 1 millimeter will be equal to 10 to the power 10 centimeter. 1 nanometer will be equal to 10 to the power minus 10 to the power 9 meter, or 10 to the power 6 micrometer is equal to 1 meter. So I'm giving you just you can pause this, and then basically here is one correction in this question. This would be 10 to the power minus 9 rather than plus. This is not 9. So 1 nanometer is equal to 10 to the power minus 9 meter, and 10 to the power 6 micrometer is equal to 1 meter. So you can try to solve this question, and then I will explain you. You can pause this video. So let's solve this question. So 1 kilometer is a km is a short form for kilometer. So kilo is always 10 to the power 3, means you have to multiply by 1000. So 1 kilometer must be 1000 meter and not the 100 meter. So this cannot be answer. 1 millimeter is equal to 10 centimeter. It cannot be 10 centimeter because 1 milli mm is milli. Millimeter is equal to m small m, and it means you have to multiply it by 10 to the power minus 3. So this cannot be, 1 millimeter cannot be 10 centimeter, or basically it should be 1 upon 10 centimeter, 1 millimeter. And 1 nanometer is equal to 10 is power minus 9. So nano is small n and m, and m it means nano. So nano is always 10 is power minus 9. So 1 nanometer is equal to 10 is power minus 9 meter. This is the correct one. And 10 is power 6 micrometer is equal to 1 meter. So this is also not correct, because 10 is power 6 micro, if you will replace the micro, and then so micro will be replaced like 10 is power 6 multiplied by 10 is power minus 6. So micro is 10 is power minus 6. So this answer is also not correct. So for this question, this is the correct answer. And we will see other units in detail